So yeah, uh, this is the Leetcode problem with closest prime numbers in the range, right? So what the problem statement is, initially you will be giving two integers, that is one is left and another is right. So you need to find two integers, num1 and num2 in this range such that the difference is minimum amongst all the pairs, right? Such that their difference is minimum amongst all other prime pairs, right? So if there doesn't exist any prime numbers between that range, you just need to return both coordinates as -1, right? So before solving this question, you need to understand what is sieve of Eratosthenes, right? Because that is the main algorithm here. It is used to find the primes in the range within the time complexity of n log of log n, right? So if anyone doesn't know what is sieve, let me clear that concept. So here I am considering the numbers between 2 to 20 range, between 2 to 20 numbers, right? So initially I'll take a vector of this size and I'll make it as, see, I'm taking a vector of bool, or you can take an array of bool, right? So I'm taking 20 numbers with the true, right? So I'm filling each index as true. I'm filling each index as true. So after you initialized all of them trues, you just start from here, right? Start the loop from 2, because 1 is not a prime number and that cannot come in the prime numbers section, right? So that's why you'll start the loop from the 2, right? So start the loop from 2. So can I say all the multiples of 2 are not prime numbers, because one and prime number should contain one and itself as a factors, right? If the 2 is becoming a factor, then it is not going to be a prime. So what I'll do, I'll go and check out all the multiples of 2 in this range and I'll mark it as false. So 4 will be eliminated, 6 will be eliminated, 8, 10, 12, 14, 16, 18, and 20. I have started from 2 and I have marked this all of them as false. All of them as false. I can show you the code. See, initially I am declaring the size, and what I was doing here, since he has given us 10 power 6, I'm giving the size of my array as that, and I'm marking all of the positions as true. Now what I will be doing, I will start the loop from 2, and if the prime of I is true, see, initially we marked all as true, right? So my 2 contains true, right, present. So then what I was doing, I was iterating from 4 and I'm adding the difference here for what is I, that is 2, right? So I'm eliminating, I'm marking that all multiples of 2 as false, right? See, here for I equal to 2, I'm internally running a for loop j starting from 4, since my prime of I is true. See, since my 2 is a prime, I'm marking all of them as false, all of the multiples of 2 as false. You can see here. I'm starting from 2, and within the for loop of j, I'm marking all of them as false. See, starting from 4, I have added a difference of I, which is nothing but 2, and again I marked it as false. That is, prime of j is equal to false. So like this, you'll just eliminate the all the multiples or all the non-primes, right? See, for I equal to 2, these are the numbers that will be eliminated. Now you'll come to 3 and you again check this prime of I is true. This prime of I is true. Now what you'll do, you'll start the for loop from 3 square, that is 9, and 9 plus 3 12, that will be marked as false, and 12 plus 3 15, that will be marked as false, and 15 plus 3 18, that will be marked as false. So the process goes on repeating like this. Now you start from 5, you start from 7, you just go on like this. And after that, you can observe that the only numbers that remained my array in my array with true is, that is 2, 3, 5, 7, 11, 17, and 19. You can see these are my prime numbers in the range of 2 to 20, right? So this is the sieve of Eratosthenes algorithm. You can watch it and can have some clarity about this. So what I was finding all the primes in the given range. So he will be giving us some left and right numbers, right? So what I will be doing, let us take this first test case, that is 10 comma 19, right? 10 comma, yeah, 10 comma 19. So you can see I'll start from the loop from 10 to 19. Since I have already marked what are primes in my prime array, so I can find out these primes in this range, right? So I'll go to 11 and I'll check if there any previous prime exists or not. If there any previous prime is existing or not. If it is not existing, I'm gonna store in my previous prime, that is my previous prime is equal to my 11, right? I was starting the loop from 10 to 19, right? So the first prime that I'm gonna get, I'll store it in my previous prime. Now if I move to the 17, then I'll check whether my 17 my 11 is giving me the minimum difference or not. I'm gonna store these two indexes, and now again I'll update my previous prime to 17, and now I'll move forward, and then I'll again check the difference between these two primes. Now my 19 minus 17 gives me the minimum difference, right? If it is giving me the minimum difference, then I'm gonna store these two indexes. See, you can see initially I'm taking my previous prime as 0, and this is my maximum difference. Since we need the minimum difference, I was initializing my maxi with the maximum difference. So these are the coordinates that we need to return. Initially I'm marking as -1 and -1. Why I was doing? Since we need to return both minus ones if there doesn't exist any prime in the given range, right? So if it is a prime, see, I'll just clearly explain. Now we already know what are the primes between 10 to 19, right? That is nothing but 11, 13, 17, and 19. So these are the prime numbers in this range, right? So these are the prime numbers in this range. So what I was doing, I was iterating a loop. See, this will give me my prime of I as true since it is a prime number. So if it is a prime number, I'm checking whether my previous prime is existing or not. See, this is my previous prime. There is no previous prime from starting to 10, since this is the starting first prime, right? So if there doesn't exist any previous prime, so this is indicating my previous prime is something other than 0, right? So if my previous prime exists, then only I'm gonna execute this code. Otherwise what I'll do, I'll update my previous prime from 0 to 11, right? From 0 to 11. Now the next prime what I'm gonna get, that is 13, right? The next prime that you're gonna get is 13. So for that 13, you're gonna check with the previous prime. What is the previous prime? That is 11, right? That is 11. So you'll update your maxi. I'll parallelly I'll take the maxi. Initially our maxi is 1e9, right? Initially our maxi is 1e9. So you can see whether the previous prime, this difference, you can compare this difference with your maxi. If it is lesser than that, then you just simply update your maxi, and you just store the coordinates at some, see here I was storing those indexes in my answer 1 and answer 2, right? So if it gives you the minimum difference, you can store those two coordinates in your some variables, right? Now you again encounter the next prime here, then you'll again check whether your 17 minus 13, the difference is giving you the minimum difference or not. You'll compare this to the maxi. Since it is greater than difference, you just don't update your two coordinates. They will be remained alike, right? So this is the main institution behind this. You can, and you again go for 19, and you again check whether 19 minus 17 gives you the minimum difference or not. Since it is 2, either you can return 17 or 19, or 11 or 13, right? So this is the main institution behind this. You can check if it is true, and if the previous prime is already existing, then you take the difference. And if your difference is lesser than the maxi, then you just update your maxi. Then you just update your maxi, and you can store those two coordinates in some answer variable, in some answer variable. So you can already see that it got accepted me as well. So yeah, thank you.